How we going, boys and girls? Everyone all right? I'll only quickly share my screen just because I wanted to chat about a couple of things. Can everyone see on-site supervision? All right, I had to fill in and teach today, so I haven't got the SIRS up. What I'm going to do is I still have to close on-site supervision. Anything outstanding, discuss it with your assessor. It needs to get sorted out because we've got 2 more assessments to mark in the next couple of weeks, and then we're doing the test, and then that's it. So what have we got, 3 or 4 weeks? Is that right? November, it's 2 weeks away. 3 weeks away. So you guys haven't got much long. So next Monday, I'm at Nowra. We've had a cancellation for the head teachers meeting, so I'm not at Maria or nothing's organised just yet. I might try and still do Maria Tuesday or Thursday because I need to get down there to you guys, okay? But bear with us, boys and girls. I'll let you know. The following week, I'm definitely going to Wagga on the Monday and Griffith on the Tuesday. All right, are there any questions, boys and girls? Make sure Adrian's going to give you the link for surveying to do your student summary. Can you get that finished for us? Because I need to close it tonight. And also closing on-site supervision. So those with any questions with marking in the background or, you know, finishing up bits and bobs, just send me, Glenn, Frank or Adrian a question, yeah? Actually, before I go, how you going with the marking, Glenn? Yeah. Right. So we're nearly done pretty much. We're on to the demo on the materials one. We've got that week in lieu, so materials is cut off at the end of the week, yeah? All right, I'm going to hand over to Adrian. Send us a message. Thanks, everyone.
All right, thanks a lot for that, Brett, and thanks. Hi, everyone. Welcome to another night. We are so close to the end now. You can almost see it, but we're just about there. So I'm just going to share my screen, and I do have a couple of things that I need to quickly bring to your attention that needs to be remembered. Just check, let me know whether the sound's all working good. I think I can hear myself here just in the background, so I'm pretty sure it's working okay. Hopefully everybody's right with that. That mouse has had it. Okay, so there's a couple of things I've opened up there for tonight on the lesson that's real important for you to make sure that you do. Technically, we can't really give you a mark into the computer system until you've done the student unit results survey. So just give us some feedback on how you went with the unit. And I've put a link up there on tonight's lesson. We're on S14, 7th of November. And there's a link there on tonight's lesson for you to make sure that you click on there and fill out the site set out survey. Okay, so that's hopefully going to take you to one of those surveys. I messaged it to everybody today as well. I'm pretty sure it worked. Maybe somebody just type in the chat pod if it worked. Let me know that it all worked okay, and is everybody getting access to that? Did anybody at all get that message and do the survey? Kamal did beside me here, so that's all good. So that's real important that you do that, and there'll be one coming up and probably maybe on Monday for the last set of units. Brett's just working on that. Now, the next really important message that you need to be aware of is to make sure that, because we'll be closing builders setting out tonight, so you won't be able to do any more with that. Now, if you're a student who isn't sure how you went with builders setting out, you're not sure if you've passed it or not, just jump onto that while it's still open and have a look and see what you receive, what mark you receive. Make sure that you've been passed okay, because I know I've got a bunch of students who I've put messages on them to do some things, but if you don't get it fixed, then you're going to have to rely on email to be able to get it sorted out because it's been closed. Now, another real important information for you is make sure that you've registered for the upcoming graduation ceremony. Most of you have probably received a message or an email from somebody, and here's an example of the one that I sent out to all the Wagga group. So pretty much somewhere there'll be information about a ceremony that's coming up in your local area. And in our particular case, we've got trades on the 10th of December at 6:30 at night at the local Civic Theatre. And you must click on the link and register to be able to go. And you've got to do that before this Sunday night in Wagga. I'm not sure what your details are down in Illawarra and some of those other places, but pretty much this just gives you the details where you put in your name and your phone number and everything. Say you're coming, I guess, and then you'll be right to go for your ceremony when it comes up, just so they can work on numbers and things like that. So that's for Wollongong. Brett's put that up there. Oliver said, can you get the certificate posted in the mail? What actually happens, in as far as I know, is every Thursday certificates are sent out from a central posting place for all of your qualifications. So not sure whether you already know this and whether I should even say it, because you might not come to the ceremony, but it automatically gets sent out to you when you finish a course, and you will finish once the teachers have put in a pass for you for all of your units, and once you've paid your fees and you have no fines outstanding. And that normally locks your course off overnight, unless it actually doesn't work, and then we have to go in and manually check. And the Thursday after that's done, you'll get your qualification in the mail. You still need to possibly ask for a transcript if you don't receive one, but you can do that at your local campus, and then you put that paperwork together and off you go to fair trading and get your license. So, but on the night, it's a kind of a celebration of the effort that you've put in, a relaxation for you because you've finished. So don't be leaving all of your work and assignments till too late, because we're now in, can't actually see my calendar down the bottom there, but we're now in the third week or something or other or second week of November. So we're pretty much going to be putting marks in right to the end, and then graduations is normally around about the second week of December. So just get your assignments and stuff done as quick as you can, and then you should be pretty right. Now, mentioning that, I've marked all of the assessment twos, assessment ones for structures for Wagga and Wollongong 2 group that I had. But however, saying that, there's probably 6 to 10 students who still have to do some work to get it completed. So just go back into your assessment there and make sure that you check to see if there's any comments or anything, if you haven't received a message from it. So that's pretty much all the administration. What I'm going to do tonight is go through roof framing. There is one more little information thing there for you, and that's to do with your final assessment planning. And you need to just hop on there and give an indication of, actually that's not quite right, that should be November 28th, sorry, and that's going to be 16:30, so I'll just change the time on that. Somehow that slipped through. 16:30, which is your 4:30. Just give us a bit of an indication of where you'll be doing your final quiz, final exam. And as I said, we're going to be doing plenty of final exam practices for you. I've got to go to, there we go, roof systems. We're going to be doing plenty of practices. I didn't actually have anybody who had any questions tonight, and there weren't that many students on at the 4:30 tutorial session, but we're going to go through some sample exams as it gets a bit closer. And if you're feeling as though you're not quite sure how you're going with things, then just jump onto the assessments tab once again, remember, and follow through so that you can check and see how you're going with your assessments and with how ready you are for your exam. There's 2 main exams that are going to come up, and there's a are you ready for the final exams self checklist that's on the assessment task, which is open for you, and you can see that. You can do a little check and see how ready you are. If you don't think you're ready, then jump on at 4:30 and ask questions about the things you're not sure about. Otherwise, you're going to find you run out of time on the night. So tonight, what I'm going to do is pretty much there's information coming up for you for tonight. Then Frank's going to do Monday night, and then Tuesday I've got next week. Thursday next week we've got a guest speaker. The following Monday we've got more content, and then pretty soon we're going to have some revision nights and assignment nights for you. So we're just about done. So tonight what I'm going through is roof systems.
Sorry, can I just bump in?
Yeah, go ahead, Brett.
Just, agents probably said it, but please be mindful, if you haven't completed that progress bar and you haven't done enough work, we're not going to let you do the test. Does that make sense? So if you haven't done enough of the work and prepared for it, we're actually going to say, nah, you're probably not ready to do it. So just be aware of that, okay? That's pretty important, because, if you haven't done bugger all work, we're not going to let you even do the test. Yeah, so please be mindful of that. Thanks, Adrian.
Yeah, thanks for that, Brad. I did forget to mention that. Keep an eye on the learning activity progress bar that's up the top right-hand side of your screen. This is the assessment bar, and those of you who have been marked satisfactory for assessment 1, that should be all good now. And then we'll be working on 2 soon. These last 2 here are the exam, but you need to make sure that you got a lot more than what I've got here, 3%. So hopefully you're getting somewhere up around 90%, and you need to be above 90%, as they're saying there. Particularly focus on those little activities and the submission activities. If you just move your mouse over them, you can see what they are. Some of those may be closed if they're a discussion point for what we were doing on the night, but those ones that look like a submission, need to work on those and make sure you've done the work. Now, make sure you learn the work, because on the last night when we do the exams, it's going to be you who does the exam, not somebody else. Okay, it's all open book. You can access all the things you need to, the online things and whatever you need to, but it needs to be you who does it. So what we're going to do tonight is spend a little bit of time just quickly looking at roof systems. Okay, so you're all good there. So with roof systems, of course, we're going to be referring to Australian standard, and the one that particularly deals with us for roofing is going to be 1684, of course. I'm just going to log on now so that I've got a nice fresh copy with bookmarks ready for tonight. And you can all do this, and you should make sure that you set this up so that you've got these all ready to go for when you come to do the exam. If we all try and hop on at the same time, that might slow things down a bit. So pretty much we're going to be working tonight with Mr. and Mrs. Smith's plans, and you may remember these ones, I'm sure. And you can see for this particular plan on our site plan, we've got access there. Just going to fire this up while we're waiting. We've got access on our site plan for 1684. We've got a diagram here on our site plan showing the type of roof. There's an outline of the external walls of the building, and this shows us the type of roof. And because we've got external corners that are 90 degrees, our hips come in on the roofs from 45 degrees. They bisect all those external corners, and that all gets drawn up by the draftsperson for this particular job. And I'll just fire this up so that we've got that there ready. This all gets set up by the draftsperson, and the roof is shown there. In this particular area here, though, that's not a hip roof, that's going to be a gable roof. So this particular roof would be called a hip and valley with a small gable. Okay, and that's the type of roof that we've been given there for our plans. I'll just fire that up so that it sits there ready to go. We'll grab this one back here again. There we go. So in this particular case, what we are familiar with is that one. And normally on the floor plan, which is where I am here, the ground floor plan, there's quite often a very light outline of the roof as well. But somewhere there between the site plan, you can see this is called the site plan here, and between the floor plan, we'll be able to see an outline from a plan view of what the roof looks like. And what I want to do just briefly here is just remind you of how we come up with the position of the roof shapes, because some of you may forget from when you did trade, or you may not have even done a trade. You might be coming from a different background. So this is pretty much the principles. What we do is we have to have the outline of the supports for the roof. So you can see all of those outlines of the building there for the supports of the roof is what is going to support the roof in this particular case. And so we first of all, what we do is we draw lines that bisect those external corners and the internal corners. So the term bisect means it's half. If you look at the angle coming across here, that's 90 degrees. So we draw a line that bisects that and turns that in, and at 45 degrees from the corner, you just draw a line across here and another one across here. And then we bisect each of those external and internal corners. Here's an internal corner here, and you can see that there's a line that bisects this. okay, and it comes in there. So this is going to be a 270-degree angle from this wall right around to there, and we've bisected that with whatever that needs to be. You can do this on a CAD or on a piece of pencil, a piece of paper and a protractor, whatever you need, but pretty much that's how we get our outline. And then we just join up our points. So obviously this line comes in till it hits that line, and that becomes the point at the top of the hip. This one's pretty straightforward here. And then one of the things we need to make sure we've done is we've found the largest outline of the building. And if you look at this building, the largest span is the distance from this wall across to that wall. Okay, and if we form a big rectangle and we draw a roof for that one, we would have a hip that comes up here, hip that comes up here, a hip that comes up here, and if we were working on the biggest rectangle, we would have a hip that comes up here. And once we've drawn that in, then we work on our smaller spans. So here's one here, and once these two join each other, then we have a line that runs across here, parallel to the external top plates, and that's called a ridge. And where it hits this hip, then the rest of that hip disappears. In principle, you can either, when you build this, you can either have a hip there or not have it there. And but on the outline from what you'd see from the plan view, this hip stops, and that becomes what we call a broken hip. So we've got the large frame, the large roof frame, then we've got a smaller frame that butts into it. And in this case, we've just got a because this angle here is a bisection of the 270-degree angle around there. So where those both meet, we have a line coming out here called the ridge. And when you look at this plan view, that's a little bit of a summary of it. We find that ridges always run parallel to the top plates. Ridges are always level. You can see an example of that here on the plan view. See, on the elevation view, that ridge runs level across there. This ridge runs level across here. This ridge is lower than that ridge because it's traveled a smaller distance. To get to this main ridge, we've gone that distance from there all across to here. To get to this ridge, we've only come this distance on the particular slope of the roof. And so you can see a little example of it there. This ridge out here out the front is lower than the main ridge there, because to get from the edge of the plates through to to directly below the ridge, we've only traveled a small distance. Whereas to get to the main ridge, we've traveled a much greater distance. That's why it's higher. So that's just a little summary of how we work out our shape of our roofs. Of course, if this is a gable roof, then this ridge will extend right through to the end and it'll stop, and you'll just have a line right through the middle of the house there, and you'd have a step down and then a line right through here. You'd still have a broken hip in there, unless this gable roof came straight through here, and then we would have a line straight through the middle of the house and a line straight through the middle of here until it hits this main part of the roof. So there's a list of principles for how to actually draw the shape of the roof. But what we need to understand is that we need to be able to go somewhere and find access to where we can get all the different parts of the roofs listed. So I'm going to just duck over to the Australian Standard, which is here. And if we look at the Australian Standard, we go down to Chapter 7. See, the Australian Standard set out in the same format as how you build a house from the ground up. And when we come to Chapter 7, we've got information here which will give us our technical definitions for all the parts of the roof. So we'll just make this a little bit bigger for you so you can see that a bit. Pretty much at the beginning of it, you've got the technical definitions for all the parts of the roof. There's an example from there, and then the chapters, all of these chapters start out with a point 1. So, and this is chapter 7. So 7.1 is general, and then there's a number of different items under there. And the next one will be point 2, and they're all building practice, whether it be wall framing, flooring and decking, floor framing, doesn't matter what it is. We have general, then we have building practice, and then the next one after that, and you can probably see that set out quite clearly here for you when I bring this across. We're going to have general is number 1, building practice is number 2, number 3 is member sizes. once we get down to number 3 is member sizes, and that's pretty much it. So they all have that same format. There's the building practice, and once you get down here a little bit, we'll start to see some more technical details of it. Right back at the beginning of the Australian Standard, we have definitions. There's always at the beginning here, there's going to be a whole section here on definitions, and you can find that normally just either from the contents on the side, if you expand them out. There we go, terminology and definitions. And as we go down a bit, we'll see actual diagrams of roofs with the different parts named on them. Okay, and so you can see there's basically, look at the beginning there, right at the beginning, there's a flow chart. And this flow chart here tells you some considerations for design using this standard. And pretty much it tells you, find the winds first, consider preliminary location bracings and things, and work your way all the way down. And that's a flow chart for design using this standard. You just work your way through and it'll tell you all the different things for design. Then you come to some diagrams which show you at the beginning, in case you don't have much of a building background, this shows you some diagram explaining different parts of the roof. And these names that are being given here, they're the technical names that we need to make sure we use. So do you call these little rafters jack rafters or creeper rafters? Well, they're actually called jack rafters in the Australian Standard, so that'll be the term for them. Okay, this particular one down the centre here would be a jack rafter crown end. That's where we get our definitions for all the different parts. You can see here we've got our Scotch Valley construction. So we call it a Scotch Valley because there's a Scotch Valley rafter or a pitching plate that's laid across an existing roof, even if it's only been existing since you finished it the day before. As you build your roof, that's a method of building another roof against an existing roof. And so all these diagrams at the beginning here, they're all of your technical definitions and things. Okay, and this is found on in section 2. So as we look up here at section 2, that's where all the definitions and terminologies and things are found. It's real important that you understand that, because that's where you get the information to be able to build things correctly. Like I said to you the other week, someone I know rocked up on the job. The lady said, "Oh, can you please build this? And I want you to build it like this, this, and this." And as he started finding out more information, found out that the plans for this particular job had gone to council. The client hadn't mentioned that. They just said, "Come and knock these frames up for us." And there were actually in those plans, there was information about the size materials and all the specifications. And if the person had just built it without going by those plans, it could have got knocked back, and there could be a dispute there about who's responsible for what as far as the materials. They might have specified 90 by 35 framing, and if that person used 70 by 35, then it might all have to come down, and that's how disputes occur. So disputes can't occur if everything's clearly stated and you're using the correct technical documentation for whatever it is that you're doing. So there's a little link here that I've opened up, and it basically just takes you straight to the National Construction Code, and you can go there however you choose to. I've actually got it for some reason, not quite sure why, but I'm not getting a, maybe I've got to push escape here. I'm just got a bit of a problem here with my screen at this moment, so just hold on a second. Can't get that up. For some reason it's not showing everything. So I've got National Construction Code Volume 2 already fired up, and so I'll show you what we're looking for here. Just come back to what we're looking for. In this particular case, we want to look at, there's a figure here, 3402, and it has roof framing part names. So I'm going to go to 3402. The easiest way is probably 3402 is just to go searching through here, and you can see I've come down here to figure 3.4.0.2, and this should match up with the Australian Standard. So this is a part which talks about framing, an explanation of terms. This is in the National Construction Code, and everything that's in here should match up to the Australian Standard. You can see number 7 there is called a rafter creeper. So I can see there's a difference right there. You have to say to yourself, which one am I going to go by? Now, it may be that there's an error in there, like I said to you, just because something's printed in a document, even by an official government source like this one, doesn't mean that it's error-free. And somewhere along the line, that would need to be adjusted. Now, this is an Australian, both of these are Australia-wide documents, and you can just be aware that sometimes that definition may be used, but you would want to note that that came from the National Construction Code, and they should all be tied in so that they all fit into the same definition. You can see this one here, they've said rafter, jack or crown end rafter, so that fits in. But you can see there's definitions and things here, and there's diagrams if you're a bit unsure about how everything works and what it should look like, and that's pretty much what I was using that for. I do want to talk here briefly about, to show you some detail about, even in the National Construction Code, we even see details there on roof flashing. So I'll go and have a look at 3513, and that's going to be down here. Just shrink this down a bit so I can get to 35 a bit quicker. I don't have bookmarks on the side of this one because I downloaded it a fair while ago. So I think I'll just go 3.5.1.3, and here we go. So just go through till we find that one there. So clause 2, volume 2, clause 3513. We're looking for metal. So this is how specific these technical documents get. This gives us the minimum pitches for metal sheet roofing profiles. So for example, custom orb corrugated iron is minimum 5 degrees. If we go all the way down to with concealed, fastened material like that, we'd normally call that a trim deck, but that may be a trade name. Then we could go down to 1 degree. Concealed fastened just means that the fasteners are kept, there's no holes put into this roof to penetrate the trays. Those parts in between there are called the trays or the valleys, and that's what's decided. It takes away the water when there's a flow. So that's the important thing to remember there. That's how specific these things can get. So that's all good for us. We've had a bit of a look at that. Now, I'll just turn this next one on here, but I think that's just access to the Australian standards. And I'm pretty sure that's been put in there for, so for Illawarra people, you just access the Australian standards wherever you need to. I've actually got them fired up here. So I'm going to go back to the quick search and hope that's still active. And I'm going to have a look at a couple of things with you just to show you a couple of things. So for example, design of timber structures is 1720. Let's have a look at that. Like I said to you, you can just sit there and type in keywords and watch what hits you get, and see and you'll find lots and lots of documents. There's heaps and heaps of Australian standards for different things. So look at this one here for timber structures. We've got design methods. That's point 1. I think we've got, comes down here, these are all superseded, so they're not going to matter. Here's point 2, which is timber properties. We looked at a table the other day for timber properties, remember, and it showed us all the different things dealing with different types of timber. I'll just fire that one up because that's quite interesting what they've got there. If we go down here, there's a number 3. This particular one is design criteria for timber frame residential buildings. There's a 4 there, which is fire resistance for structural adequacy. In this one here, this particular Australian standard shows us timber properties, and it goes through. The first thing to look at pretty much is have a bit of a look at the contents. Okay, and that's real good. The tabulation of species and properties. It's repeated in Australian Standard 1684, but it'll tell you at the beginning what this is for, where it says scope and general. And you can see as we go down, it'll give you references to other Australian standards or other documentation. And as we go down, we see one of these great little charts, which I'll just tip that over so you can see. And this has a huge amount of information that's of interest to us that we need to be aware of. So if we pick this first one, for example, index number 8 is an alder rose. I don't actually know whether anybody's ever familiar with that one, but let's look at the second one here, alpine ash. And it says origin NTV. So somewhere up here there'll be an origin. Actually, the explanation for it, I think, is down here. So origin is listed here. N is New South Wales, T is Tasmania, and I thought there was a V or might have been a Y that was there. So this tells you where it comes from. And then it says species. This is item number 4. So across the top here, we've got numbers 1 to 18, and 1 to 18 refers to written information that's here, explanation of the table, 1 through to 18. So if we stick with Alpine Ash for a second, and we look at Alpine Ash, it comes with a species brand of AA that would be defined in point clause 4. Then we have a classification of H. We have a strength group there listed. We have a joint group, which comes into our fixings and tie downs in Australian Standard 1684. We have a density. We have a hardness. We have a tangential cleavage. We have a toughness. We have a shrinkage, which is real important. This particular one's 8.5. There's a little double-headed square there, so that cross that. So that means refer to more information at the bottom of this group of tables. We have natural durability class in ground is a 4. 0.15 would refer to that and tell us about that. And outside above ground is listed as a 3. If it's susceptible to lictus beetle, then that would be listed, and 0.16 would tell us about that. Termite resistance would be in number 17, and marine borer durability. So there's a whole heap of information for all different types of timbers and things there. And that table is at the end of 1684, and also in this Australian Standard, which you can see we've had a hit with there. So that explains that a bit. We also have in 0.5 is design of nail-plated timber roof trusses, 1720.5. In 1684.2, we've got the non-cyclonic. 0.3 cyclone areas. 0.4 is a simplified version. So all of those is an example of some of the standards that are going to be relevant to us for our use. Now, if you're not quite sure about pitched roofing and how to pitch them and things like that, there's a video you can watch in your own time from Build Some that's available for you, and that'll give you some good information there on your roof systems. So I'm going to open up this first activity, which is your traditional roof system. And in this particular case here, it says, from your own knowledge, sketch the Mr. and Mrs. Smith plan and submit this via snapshot here. Consider the roof structure to be pitched as per conventional method. So what we want you to do with that one is just grab a screenshot, let's say, for example, of the floor plan, because it hasn't got a roof plan quite so marked on there. And if you just push the print screen button on your computer, which is in the top right-hand corner, and you can come back and grab a Word document if you like, or whatever type of document you'd like. I'm just going to have to try and grab, here I've got a Word document there. So just grab a Word document and pop that picture in there, and then you can just leave it as it is if you like. And I'm just going to tip my page over to a landscape view so I can see just a little bit more. And what we want you to do with that one is, I'll make that as big as I can. What we want you to do with that one, without referring back to the diagram, is see if you can draw the hip roof in there. So the easiest way to do that is to insert a shape and just insert lines, and grab one line that goes from the corner of the building. Okay, from the corner of the building across, and just run it across at about 45. You can probably estimate fairly well. It's going to have to bisect these external corners. So the one coming down there and the one coming down here. And you can just grab the corner when it becomes a movable arrow, and you can turn it around like that. And now, because you've got one line there like that, you can go and grab another one, or just go Control-C, Control-V, and that'll grab another line, the same. And I'm going to put it out about here somewhere. I'm going to grab this corner and spin it around, and you can kind of estimate and put that on a 45-degree angle there somewhere. Just do that as best you can, just estimating in here. And in this particular case, I'm going to put a hip roof up this end. So I'll make this one a little bit shorter here because they actually meet right there. So I'm going to put that in there. I'm going to grab another line here, which, and I'm going to make a gable roof down this end. Okay, so in this particular case, I'm going to have the line that starts right in the center there, and that's going to run through till it hits this one. And then I'm going to have another line that starts here. Oh, just got to grab that line. I'm going to bring that line through there. Actually, I need to make these lines a whole lot bigger because you all can't see that too good. I'm just going to format these shapes and give them a big fat. Make them nice and fat so you can see them all a bit easier. I think that colour's probably all good, so we'll stick with that. And then this one here, I want to bring right through to here. So in this case, that's I'm going to put a hip roof down that end and a gable roof up this end. And I know the activity asks you just to do, I think, duplicate the roof, but I think it'd be quite good for you just to put in there your design of a roof. So if you want to have a hip down here, do that and make a design of a roof yourself. But it must be the type of roof that actually works. So in my case, I'm going to have a hip roof run against there. There's going to be a gable roof down this end. That's going to be a hip roof. Sorry, this is a gable roof here. And down this end, I'm going to put another little roof. So I'm going to grab this line here. Oh. Just grab this line here and I'm going to put that, I'm going to put myself a little hip roof here. So I'll make that a bit smaller. That's going to go about halfway. And this end can come around here so it can fit in there. And then I need another one that runs in through here. Actually, we'll just delete that one. Pretty much I just grab two of those. Oh. Bring them down here. So these particular ones, because remember we bisect the external corners. I've bisected this corner and I've bisected this rafter coming across here and this one there. So I've bisected that. And now I'm just going to grab another one here that I can make for the ridge. Bring this around here. Now the principles for doing all of this is, so that's pretty much my roof. Okay, and that becomes in that case, that becomes a gable out there. This becomes a gable in here. That becomes a hip, that becomes a hip, and that's pretty much what I've got on there. So there's lots of different ways you can do this. You have a little bit of a go at that and set that up for yourselves. I'll just take a snapshot of that, and if you want to access SketchUp, you can quite easily do the roof on SketchUp and it'll automatically do roofing for you as well. So I'm just going to look down on top of the SketchUp here. And I'll just spend a couple more minutes explaining this to you. I'm just going to turn off, ignore that, turn off my axes, get rid of the person there, and I'm going to import, I'm going to put that picture in there that I took a picture of. So I've taken a snapshot of that. I might leave it at that. Actually, I won't go too much into this because you're going to get a bit too confused. If I just draw Mr. and Mrs. Smith's house, the first thing you have to have is the first rectangle, and then we've got another piece that comes out here. And in this case of their house, I think from memory, they've got a bit that comes out the front here. Yeah, that's pretty much it. So we've got the main outline of the house. And in this particular case, if we're going to draw our lines and things in there, we're pretty much going to need to set out what I showed you. So we're going to have to do that pretty accurately because that's a CAD. But with this particular program, you can draw all your lines in and you can tell it to automatically do the roof for you. Okay, so I probably won't spend too much time doing that with you just now, but if I draw one end like that, and then if I select this one, if I remember how to do it, I'm pretty sure that's the follow me button. So that becomes your roof. And then all we've got to do is go through and just clean up all the little shapes and things that you've got there. as they fit in. So you can get programs that do this type of thing automatically. You just have to intersect faces with model. You just have to make sure that you've had a bit of a go at understanding how our different roof things work. So that's an example of the roof there, of how that works. And there are programs and things that do this. Like I said, you're not going to have to do this yourself, because the plan drawer is going to be the one who gives you a plan that's already got this worked out for you. Okay, but just as a quick example, that's an example of how that roof could work. And there I've drawn it pretty much as a hip roof. Okay, all the way around. Where's that one there? And there's an example of your roof. So there's lots of different tools and things that are available. What you need to do is just get something there so that you can get it put up on the site as a submission, and you'll get yourself a little green box in the corner there. So I've opened that one up for you. Now, once you do that, there's a roof quiz that'll be available there for you as well. And I'm going to open that at the end for you. So I can show you what that looks like. Now, there's an example that Brett's put up of all the different namings, just to help you with some of the different names of things. And I'll open that right at the end as we go through. Now, while some of you I know will be doing this as you go through, just going to go through and open up this roof. I'll just have a quick look at this roof discussion. Okay, so you can work on that as we go through. That won't be too hard for you. Just want to show a video here on trusses. What we're going to do now is have a quick look at a truss roof system, and just quickly familiarise you with this, and then we'll go through and touch on another type of roof system. Then I'll open up the activity so you can go for it. So there's actually this one you don't actually need any sound for, so I'll just show this on the screen and you can just watch it. Pretty much what happened here was, pretty sure Brett could probably explain this a bit better, or Glenn. You guys went and did a visit for a truss plant, and these are some examples of a typical truss plant. So you can see this from pretty much check out from any truss plant. They all have the same type of thing. There's going to be stacks of timber, and there's somebody who sits on a docking saw, which is a really big compound drop miter saw that can cut all these fancy angles. And that's how they make up the trusses and things. So they stack them up on pallets and things like that. You can see there's a lot of the ancillaries and things that'll get sent out, or the gang nails in that particular case. Here's our pieces of timber. So somebody's job is to cut all those up. And then there's lots of different types of plus trans systems around. In this case, they have stations that are set up and locked in place. And that's the beauty about trusses, is that you set this station up once and you can quickly pump out a truss the same as that, as long as it's exactly the same as that, every couple of minutes. They're real quick to pump out, and you can pretty much just push everything together. In this case, they've stapled them together. We used to have one of these when I was working in the industry up at the Central Coast years ago, and we had lugs that sat up there, so that when you put a piece of timber in there, it didn't even need stapling like that, because there were lugs, little posts that stood up, and the piece of timber only fitted in one particular spot. And then what happens is these gang nail plates, to an Australian standard. Remember, I showed you there's an Australian standard for nail plates. They are actually put on the top and the bottom, and in this particular case, the press just presses down on the top and the bottom, and that's probably a minimum of 20-ton press that presses that down and puts it onto presses the gang nails together. And then you end up with them real tight together, and you end up with a structure that is made up of lots of small pieces of timber that are gang nailed together to form a really tight structure. You can see here how we're working at everything at bed height. They've got all the webs and things that are sitting there ready to go, and the number of those webs is probably the number of trusses that are that particular size and shape. Here they are put together, ready to be trucked out, bundled together, and this is what you see coming out on the site. Okay, so that's an example. There's a video in there you can have a look at as well, and that's a good example for you of how truss works. Now, BuildSome's got another video there for you to be able to have a look at that explains some of the different parts of a trusses. And here we have another video here, understanding forces on a roof truss, BuildSome, so you can have a bit of a look at that. And then there'll be an activity there which talks about truss identification and terminology. and I'll open that in a little while. Now, trusses are manufactured usually by a company. In this particular case, you see a name there called Prider, and that's one particular company who manufacture trusses. And what they actually supply to people, to organisations and businesses, is a full system that has all the technical details, the design software, and all of the information for a company to be able to take that, set up a factory like I showed you before. This particular case, it's Prider, who's a big engineering company for building supplies and things. And they pretty much set up a whole system so that people can walk in with a plan like that and say, give that plan to the truss company of Prider in this example, and say, design me the trusses. And then out come the trusses on the truck, and you install them according to the truss plant manufacturer's details. Okay, so whatever, they'll send you documentation that comes with that, and that pretty much is what you have to follow. But it'll be also in alignment with the Australian standard. So in this particular case, here's Prider with layout software, and they actually help you. There's a YouTube video which you can, I'm not going to play that now, but that pretty much goes through information on loading multiple trusses on a layout. So it gives you an example of how trusses can be laid out, and you can watch that one there. Okay, so then there's an activity which you're going to do pretty soon, and that activity is pretty straightforward. That pretty much says refer to the truss roof student doc, okay, which is there, and it says view the plan view that's required, list at least 10 steps to successfully organising the construction and completion of the structure. So I'm not opening that right now, but there's some, I put on there the student document, so that gives you your room there for your 10 steps. And then I've also put in there a MyTech, and I think that's a different guide, might be from one of the other companies, to be able to help you with that activity. And you can do that activity in a minute when I finish talking and I open that one up. So let's have a quick look at this next thing here. So here we have a steel brace example for the top plate, and Brett's asked the question there, and you can type in the chat box an answer to this. So your question is, this is the detail from Australian Standard 4440. Do you fit bracing in the correct manner? So in this particular case, you're not going to remember the names of the standards, but as I said, if you type in the search box for Australian standards, bracing or things like that, or truss roofing, that's actually the truss roofing standard. That'll tell you the correct way to brace. So this one here is the end fixing details at the heel to the top plate, and this is the end fixing details at heel to top plate, an alternative method. And the questions come up there. Do any of you fit this the correct way? I'm just reading the chat box there. So just type in the chat box. Can anybody say definitively, yes, they do fit their bracing, their truss roof bracing that way? Yes, says Riley. Maybe you can type in, if you're going to, the no's. There's going to be somebody here who doesn't. So you got two alternatives there. One is to wrap it right down. You must use the nailing as per the details, and if you're going to wrap it, if you're going to just wrap it across the top, you should be putting a little trimmer in between those trusses. If you're going to wrap it right down over the top plate, you come across it at less than 45 degrees, and you run underneath the top plate, and you must do exactly what it says there. So we would get this information from the truss brochure, truss documentation that comes with your set of trusses. Okay, and so there's a discussion here for you. Are you using correct compliant bracing material? Discussion about what the standards apply. So in here, there's a quick checklist thing there. Prider has put out as a notice, and that potentially could be sent out to people. It would have been used in a seminar or something possibly, and there's a few pages there that you can look at that talk about how it's important that every single piece of material used for trusses must be compliant, and it must be what comes out from the truss manufacturer. Okay, so you can have a bit of a look at that, and there's Australian Standard 4440, and I'll open that up for you, and that's obviously something that's going to come through. You can get that from Australian standards, and that's 73-page document that shows you all the information about installation of nail-plated timber roof trusses. And that will be summarised when you look at the booklet that comes out with the trusses. Okay, then there's going to be a quiz on that. So there's the document, there's the quiz, and you can work your way through that pretty soon. And I've put on that quiz also a link to that document in case you open up the quiz, forget where the document was, you can actually access it there. So that's all pretty good. I've pretty much finished talking about manually pitched roofs and trussed roofs, and they're the two main types of roofs that are used in Australia. Now, went to Western Australia last year, I think it was, or it might have been the year before, and looked around over there. Most of the homes are cavity brick construction, certainly around Perth, and most of the roofs are pitched as a timber pitched or they're steel pitched. And that's just what happens in a lot of houses in Sydney, apparently, I'm hearing, pitched roofs as well. And some of the reasons for that could be that if you're a bit short on work, then pitching a trussed roof yourself means that you can give yourself some work. That's going to give you a couple of weeks' work right there. Or you can outsource that work to the truss factory and let them do the work while you go surfing or do another job. So most people out in this district will get a truss factory to make the trusses, and lots of them get them to make the frames as well. And then if they're busy and there's plenty of work, then they'll just stand the trusses and the frames. But if you decide that, or the client decides that they want a different type of system, then we're going to spend a little bit of time here looking at some of the different innovative roof systems. And I want to stress here that it's real important that whatever type of system you choose must meet the National Construction Code requirements, which allows for innovative type roof systems, or it allows you to go for systems that are traditional or conventional roof systems that are in the Australian Standard 1684. But if people make their own, if manufacturers manufacture things that aren't in the standards, then they have to produce the documentation to be able to manufacture, to be able to do things that aren't in the Australian standards. And in this particular case, we're going to now look at a couple of jobs that are available to you as innovative roof systems. The first one is the Rytec roof panels, which basically consists of ColourBond on the top, ColourBond on the bottom, and foam infill in the middle. And I've built pergolas out of this, and it's quite good. It has huge spans because it's a laminated type material. And one advantage of it is that when the sun shines on the top, the heat doesn't transfer through to the bottom. So you can get a pergola that doesn't have any heat coming through from the ColourBond being cooking hot from a hot summer's day, which is great. You can have big spans. There's no finishing off of the job. Just screw it together and it's all finished off. But there's lots of advantages and disadvantages. And we're now going to have a look at a Rytec roof panel system. And we're going to look at some information. Then there's a quiz. And then we'll look at the Bondor roof system, which is a little bit different type system. And then we'll have a look at a cost comparison activity. And that's what we're working on tonight. So the first thing I want to do is just run a video. If the teachers could prime up their video. I'm going to turn off the microphone here, and we'll run this video and then come back once you're finished.
Oi, the video's not up.
Sorry, I think I mucked that up and I didn't put the video on. So have you all finished there? You can watch it yourselves in your own time anyway, but there are a couple of things I want to show you with this. I'll just get it so it's big screen and we can see. Hopefully you can see here. I just want to show you a couple of things with this particular product. I'm not going to play the picture, but there's an example where they screw it together and you can see the big long screws they use to screw it. We've built a big pergola like this. You can see, for example, that screw is long enough to go right down through both pieces of, it's just like screwing normal corrugated iron on through custom orb, and the screw goes right down through into whatever's below. And it's a big long special screw. So these companies are the ones who supply all the information. You saw one of the pictures here right back at the beginning. The guy was installing some foam. I think it might have been right back where they started talking about it. He was installing just here. He was installing foam across the top to sit the panel on. Obviously, that foam's got to be real long lasting so that it doesn't deteriorate like the foam underneath the bonnet of your car breaks down after a while and just falls off. That's got to be real long lasting so that it can last the life of the building. We have to make sure that we build according to whatever the instructions are on the technical site for that particular company. Sorry, I didn't show that quick enough, so you probably missed a bit of that, but it's you can have a look through that a little bit later anyway, and there's some questions there for you, and you can just run the video and answer those when that comes to it. So I'm going to open that up a little bit later. I'll open all those activities up. This next product is a bond door, and this one here there's a couple of questions there, and I'll open that up for you so you can have a look. And there's a technical bulletin number 16 from BlueScope, which explains some of these things. And pretty much what you're looking there is to find out how are these things fixed and where do you find the information. So I'll turn the microphone off here. That's showing this time. Sorry about the last one. I'm just going to open up the Bondor website as well. So I'll play this video, which goes for a couple of minutes, and there's the Bondor website. I've put in there a link to the technical bulletin from BlueScope, who deal with the Bondor, so you can see how it's fixed. And we'll play this video and then come back once I've finished. Okay, I think most people are probably done there. That'll be right. So your activity now is what we'll do now is have a look and see how those sheets are fixed. You saw a little bit there on how that's fixed. There's a technical bulletin that I found from BlueScope, the closest I could find for this Bondor type product, and these guys are the manufacturers, so they have information on how things all fit together. In this particular case, they've got a fastener table, and they'll list the type of fastener according to, once again, an Australian standard 4312. So in this case, it's metallic coated screws suitable for corrosivity category 3. That's if it's these particular ones. And you work your way down to find the different types of fasteners. So most of the products that goes on either side of these specialist alternative roof systems is going to be a Colorbond type product if it's manufactured by them. And that's going to, so whatever their fasteners are, that's what's generally used. Look at this example, for example, underdriven, overdriven or correctly driven fastener. You shouldn't have the washer bulging up underneath. It should be pretty right. So you can usually set your drivers to be able to stop at the right spot. And this is one example there of how fasteners are chosen. Okay, so that pretty much answers that. Now there's an activity here, a cost comparison, and I'm going to put this up, but that's not the main. There's an activity and thing down there as well, but pretty much this just goes through and says, okay, there's that bit there. If you're thinking about a cost between the different types of roofing systems, the guy in the video spoke about it a little bit. He said the crane's there for more, but we've got the roof done a lot quicker and people can get into the job a lot quicker. So people, if you're able to offer to a client that you can get them into a job a lot quicker because you've used a different type of product, even if it might cost a little bit more for your build, that can sometimes be real attractive to them. Depends on what their motivating factor is for their job. So there's an activity that's here, links in with the roof cost system cost comparison that Brett set up there. And he's put in an example of a traditional roofing system. So if you look at roof sheeting, flashings, insulation, battens, rafters, fascia, joist hanger, guttering, downpipe, gyprock, cornice, the whole bang lot, and you work your way down and you could come down to $4,280, for example. And sometimes if you can use some of these alternative type systems, so that's an example of what's in there, the traditional roofing. Then sometimes if you can use some of these, for example, Rytec, it might cost more, not a lot more, but you can end up basically eliminating a lot of these products. So the roof sheeting, you're going to need that anyway. Your flashings, you still need some flashing, but not quite the same. You don't need your insulation because it's incorporated. Don't need battens. In some cases, I know when we built one of these, we didn't need rafters. The fascia was incorporated into it. We didn't need the joist hanger. The guttering, we did need some guttering. Downpipe, we didn't need any gyprock, cornice, any plastering, base coat, top coat. We needed roofing screws. We didn't need bracing nails. We didn't need eave sheet. We didn't need any gyprock glue. And this particular activity here, as I've indicated to you back on the main page here, jump back here to our site. That's not even considering painting. So when we look at that cost comparison, that doesn't even consider painting. And so your activity, your job now is to work your way through these in this particular last exercise that we've got here. There's an activity for cost comparison, which you'll work through. And what I think I'll do now is open all of these up for you, and then you can start working your way through these, and I'll just go through, and then I'll start at the last one and just start working my way through. We can stop the recording and just start working out. I'll just start working my way backwards so that if you get stuck on anything, you can just watch us, and you should be right to fill out the activities that are there for the evening. So open all these ones up. There's your discussion answer. There's a roof quiz. You can jump on now and grab yourself a few more green boxes. So I think I've opened everything up there. Managing and coordinating truss roof planning.